So we're getting there on the word problems. These are mixture problems. This is the second to last kind of word problem that we've had, that we'll have. And the mixture problems are really, like they say, when you're adding a bunch of things together. Now, I often talk about the bulk food section. So I can't believe I'm putting this in a recorded video, but I think most people have done it or seen it done. If you want to buy some mixed nuts, but you really like cashews, in the bulk food section, you can actually mix some cashews into your mixed nuts. So we've had two different kinds of things from the bulk food section. We'd have the nuts, right? The mixed. And then we'd have the cashews. And ultimately, we would mix them together. And if we were being honest and truthful, we would pay the adjusted price based on how many cashews and how many nuts we have in there. So this idea that this is the total, right? This is the total mixture of different kinds of things, whether these are different coins, different tickets, different kinds of things. So different substances. We're going with the nuts in the bulk food section. So when we sort our information in these kinds of questions, we're going to talk about the amount or the number of things, and we're also going to talk about the value of them. So mixed nuts are, let's just say they're $2 a pound, and cashews, let's just say they're $3 a pound. So in this analogy, we would have a total amount of nuts. Let's just say we have 3 pounds, right? And we know we have X amount of mixed nuts. Well, the amount of cashews that we would have would be 3 minus X. Now, this order absolutely matters. This is the total minus the other part, right? X minus 3 would be a totally different concept. So the order matters because we have a minus in here. So we're going to have our let statements in these boxes. And we're going to come up with our value line down here. So it would be $2 times the amount of mixed nuts that we have. And it would be $3 times the amount of cashews that we had. So should we want to mix the cashews in, we should actually do this kind of algebra and not just sneak them in and be billed out at the mixed nuts rate, right? So that's what I'm saying. Never done that before, I'm sure. So anyway, that's the idea here. This question doesn't actually work out, so there would be a total of however many dollars. All of these things are often given to you in the question. So let's do a couple questions like this. The key thing here to notice is that we've got part A and part B, whatever those things are. We've got the number of things here and the value of things here. And we have this concept of the total number and the total value down here. And that's really the sorting system for these mixture problems. Let's see how this system relates to these different kinds of questions. So this one says that we've got some tickets for a school play. We've got general admission tickets and student tickets. We've got two different kinds of tickets are contributing to the total of the tickets at this play. So we'd have two parts and a total. These are going to be the general $4 tickets, and these are going to be the student $3 tickets. Okay. Says that 400 tickets were sold for the school play. Remember, this top row across is going to be the number of things. The bottom row is going to be the value of things. Now, 400 would go in the total number of tickets for the play. The other thing that says here is that the total value of tickets is 1,350. So from this information, we want to know how many of each kind of tickets were sold. So we're going to have to come up with some X statements. I'm going to make my general tickets X, and my student tickets, I'm going to come up with the expression of the total minus that number of general tickets would represent the number of student tickets. And again, it's not x minus 400, it's 400 minus x. It's the total, taking away the other part. So I've come up with my two let statements. That is 1 mark when I'm taking a look at these. You don't have to write individual statements. The boxes count. I need to come up with this value line down here. So it's $4 times the number of general tickets, which I'm representing as X, and it's $3 times the number of student tickets, which is a bit of a lengthy or sizable expression. So it's that 400 minus X. So check this out. In these questions, if I fill out the boxes, I have crafted my equation right down here. So it's this plus that equaling that. And I can just copy my equation right out of my chart. And so I'd have 4x plus 3 times 400 minus x equaling 1350. So I've got my equation built. All of that really in the chart. So now I need to solve my equation. I distribute the 3 all the way. And now I can collect up those like terms. I get x plus 1200 equaling 1350. Subtract 1200 from both sides, and I'm going to get that x equals 150. So now I need to take a look back. What does that actually represent? So that's the general. So it was 150 general tickets. And same as what I've been doing, you take that back to your let statement to figure out the other thing that we're looking for. So it's 400 minus 150. So we have a total of 250 for that. So that's 250 student tickets. These kinds of questions are a little bit more complicated. I really love how the boxes do the sorting for you and build this equation little by little, because if I was asked to come up with this equation, like just off the top of my head, I don't think I could do it, but I can pull it apart little by little and build that equation. And once I have the equation, it's just the mechanics of solving the equation that I have to work with. Okay. So this question is about Beth, and that happens to be my mom's name. So I always imagine that this is my mom out doing this. So my mom's going to go buy 40-cent stamps and 3-cent stamps. I don't know if we can still do that these days, but whatever. She's going to buy 92 stamps total for a cost of $22. So how many kind did she buy? Okay, so I've got two different kinds of things coming together. I've got the 40-cent stamps and the 3-cent stamps. And I've got this idea that they're going to combine to a total because it's a mixture of things. And just to remind us, on the top of my charts are the number of each of these, and on the bottom is the value of each of these things. So there's two numbers that I can fill in here pretty straightforward way. That's 92 stamps, that's the total number of things. And this $22 is the total value of things. The next thing I need to do is turn my attention to my X statement. So it doesn't matter whether you make the 3-cent stamps X or the 40-cent stamps X. One's going to be X and the other is going to be the total minus the other part. So this would add up to 92 stamps. So I've got my number of stamps and now I have to craft the value of them. So I've got a problem here in that the stamps are in cents and the total is in dollars. So when I see 40 cents written out in dollars, it would look like that. So that's going to be the coefficient on my X term. It's 40 cents times however many stamps were bought. And the same with this 3 cents. If I wrote it out as dollars, it would look like that. So it's 0.03 times this 92 minus X. That's the number of the 3-cent stamps. So again, in this one, I love changing color so you can see it. This is my equation, right? This is the total value that I can solve for my X amount. Okay, So I've got 0.40x plus 0.03 times 92 minus x, all equaling 22. There's a lot of decimals here. You can use your calculator for these. There's another way if you're starting to get itchy thinking, why is she doing it that way? There's an easier way. If you don't see it, that's cool too. I'll show you once we're all done. This second distribution is something that I always miss, not always, but often miss if I'm going to make a mistake, going all the way with that. Next thing I can do is gather up the like terms. This one always makes me nervous. I think there's no way it's going to work out. They should always work to whole numbers. If they don't, something's gone wrong. So I get that x equals 52. And that tells me that there were 52 40-cent stamps because that's the x that I see in my chart. So it was 52 40-cent stamps. And again, this idea that the 3-cent stamps were the other part of 92. So it's 92 minus 52. So we get a total of 40 3-cent stamps. So there we go. It's certainly easier just to count how many stamps. I don't know the practical applications of this, but it does illustrate this idea that you can take a complicated problem and break it down in order to build it back up and get an answer. The next question here, again, futile. So it's about a bank teller. And the bank teller knows that she has 125 bills. All the bills are either 10s or 20s, and she knows that the total value of them was this. Instead of her just counting how many of each kind, we're going to do algebra to figure out how many bills of each denomination she has, okay? Totally not a practical solution. So the two kind of things that we're mixing together here would be $5 bill, oh no, $10 bills and $20 bills. And the idea here is that these two are going to mix together into a total. And we'd have a total number of things and a total value of things. It should be starting to get easier to fill in some of these blanks. So the total number of bills is 125 and the total value of bills is this 1650. These are also pretty repetitive. Once you've got down the x terms, one's going to be x and the other one's going to be the total minus x. We don't have the same problem in this question as like dollars and cents. So it's just 10 times the number of $10 bills and it's 20 times the number of $20 bills. So this gives me my equation to solve. What is that, 2? Always makes me nervous when I get negative coefficients on stuff, but I get a negative 850 over on this side too. So everything works out and I get an answer of 85. And again, that answer is only part of it. That gives me the number of $10 bills. So she had 85 $10 bills. And then she has 125 minus that 85 for the number of $20 bills, or 40 $20 bills. And I don't always show my work on that. I would just probably look back here and then do the math. So 125 minus 85 on my calculator gives me that 40 of the $20 bills. So I find that, 3 examples like this, usually people are hitting their stride and it's feeling pretty good. This next one's a little bit different, but not all that different. So this one says it's about admission again, so tickets being sold to a cricket game, and we've got $6 seats, we've got $5 seats, and we've got $3 seats. This time we're going to have 3 different things mixing together. And this one's slightly different in our X statements, but not that much different really. Okay, so we got the 3 things coming together to make the total. And the 3 things would be the box seats for $6 and the grandstands, I'm just going to do GS for $5 a ticket, and then the bleachers for $3 a ticket. Okay, so the top parts of the boxes, as we know, has the number of tickets, and the bottom is going to have the value of the tickets. Now, it says the total receipts for the day were $9,000. That's going to go in the total value of things. It doesn't give me the total number of seats. In this one, I'm going to have to see what other information it gives me. So it says 100 more grandstand seats than box seats and twice as many bleacher seats as box seats. Everything that we're comparing to are the box seats. So that's going to be X. And now I'm going to have to read back. So it says 100 more grandstand seats than box seats. So the grandstands would be whatever the box seats are plus 100. And it says twice as many bleacher seats sold as box seats. So whatever box seats are, it's going to be times 2. We don't know what this box is, nor are we being asked that. We have enough information to go because we can use this number of things and the value of them to build that total value line. So the number of box seats would be 6 times X. The value of box seats, the value of grandstand seats would be 5 times X plus 100. And the bleachers would be 3 times the 2X. So again, this bottom line is what's going to give me my equation. It's going to be a little longer. Recopying it carefully, hopefully. We're going to use some distributive property here. The 5 has to distribute through that bracket, so 5x plus 500. And I'm going to do this 3 times 2 as well, so we get 6x equaling 9,000. Can gather up my x terms. I've got 3 of them there. So what's that? That's 17x plus 500 equals 9,000. I'm going to subtract 500. My writing is getting really messy. Divide both sides by 17. And this works out to, what is it, 500. All right, so that only tells me one of these. That tells me it's going to be 500 of those, but then it's going to be 500 plus 100 of those, and it's going to be 2 times 500 of those. I'm going back to my let statements here, right, with my X value. So my final answer would be 500 box seats, 600 grandstands, or tickets or seats or whatever you want to do, and then 1,000, that looks like a 7, 1,000 bleachers. Awesome. And again, this is just my rough work to show where I got those final answers from. Last one on mixture problems, we have Marzena, and she's going to inherit $5,000. Lucky her. She's going to divide that 5,000 up and invest part of it at 4% and part of it at 3%. So these are the 2 parts that I'm mixing together, are that 2 amounts of money at different rates. So this one's going to represent the 4%, And this one's going to represent the 3%. That's not how much of her money, but that is the rate she's getting on it. So this is going to be my totals box. And again with this, to just build it up slow, this is the amount of money. This is going to be the value of interest. Okay, so she's got $5,000. That is her total amount of money. That means that she's going to have X of this and 5,000 minus, whoops, that's 500, 5,000 minus X in the other amount, the other rate. How much is she invested if at the end of the year she gets $180? So that is the value of interest after that first year. So we need to write this percent as a decimal. So that's 0.04 as a decimal, and this is 0.03 as a decimal. It's kind of like turning the cents into dollars, but this is rates into decimal values. So 0.04 times X and 0.03 times 5,000 minus X. So in this one, we can build up this equation. And I actually said something that I didn't follow through with on an earlier example. So let me just write out this equation. And one way that you can deal with these, or the one that was like my mom buying the stamps, is you could just multiply everything through by 100 and get rid of these wacky little decimals. So if you did it that way, that's great. If you didn't and doesn't make any sense what I'm talking about and this way's working, then go for it. Don't change anything. So I like using my calculator on these ones. Don't forget to do the second distribution as you're working through. I'm going to gather up those like terms. I'm going to finish by subtracting 150 from both sides. And I get a final answer of 3,000. Now, that is then $3,000 at 4% and $2,000 at 3%. Because I did the 5,000 minus 3,000 as my answer. There's one more kind of word problem to do, which are the distance, rate, time, or the motion problems, sometimes called the DIRT problems, but we're almost there at the end of our word problems.